Ackerson, and he'll help us understand the challenges and solutions when implementing LLMs in enterprise contexts. Thank you, Noble.
Hello, and thank you everyone for investing your afternoon. I hope everyone's learning a lot. It's been a phenomenal set of presentations so far. Peter Norvig helped us understand how these things work. Alan gave us some insights as to how to talk to these to generative AI solutions. Victor just now sort of showed us a practical example of how showing the power of these tools, and I'm going to sort of just take a beat, a left turn, and sort of show how, in an applied sense, we're also using these tools in the enterprise. This talk, if the title sounds familiar, is from a Towards Data Science publication that I wrote in February. And so we'll jump right into it. And thanks again for the organizers and everyone involved for putting this together. All right. So to get to done in about 30 minutes or 20, you'll be taking away why unreliability of these generative AI systems erodes trust in the systems that we build with generative AI. It's an opinionated take. From an enterprise context, I want to show how these systems are used. So it's a field report of some sort. I'm going to then sort of use examples to share why these systems behave the way they do and why they're unreliable information sources and stores. And then, of course, share what is being done about that, at least in the context of my line of work. And so I will, of course, leave some key takeaways and some links and resources at the end of the talk. And I hope to post this slide when I'm ready to share it. All right, so generative AI tools, we've heard a lot about them today. They're, large language models, super powerful, right? There's a chance that these tools will be ubiquitous or ambient in our lives, if they're not already. The notion that based on how they work, that an autoregressive system that lacks a cognitive architecture or deductive reasoning, the notion that these things are blind to what they know and what they know they don't know, those would be incorporated into consumer like search, for example, actually terrifies me and continues to terrify me because of the world that we live in with, misinformation, disinformation, that kind of stuff. And this is a concern for enterprises, right? And so in my opinion, generative AI will always be an unreliable store. These systems are improving, though. And so as you can see on the screen, one of the first things I do with any new state-of-the-art model, this was back in February, I ego surf. I Google myself of sorts and try to find out what the system knows about me. It's a very egotistical practice, but what way to evaluate a few shot or zero shot approach to testing a response by searching for something that you know a lot about, which is me. So back then it told me I was dead. I was a successful entrepreneur that actually died. There are some half-truths in there, and that's almost a blueprint for misinformation if you do not know what you're working with. And so that's why it sort of frightens me to be tightly incorporated into search. But joke's on you, ChatGPT, at least the earlier version of it back in February, because I'm still alive. I think I am. I'm the director of product at Venterra Corporation, a technology firm in Northern Virginia, and I work with federal customers, try to be responsible in how we incorporate data and AI models into production applications to help U.S. taxpayers every day. On my personal side, I also run a company called Byte and Atom Research, where I work with mid-sized enterprises to help them think through their data trust strategy. And in that, I'm just focused on bringing reliable, trustworthy, and responsible data governance to applied learning context. So Biden Research is essentially an applied research firm, applied research and development firm. And so that's about me. This stuff that I'm about to talk to you about today is what makes my heart sing, right? I want to be a great ancestor to these ubiquitous tools, tools that are eventually going to be ambient for me, my children that you see here, and you, right? So let's dive right in. As I was listening to all the previous talks, I started trimming back my slides because it was well covered. And so I'm going to sort of breeze through some slides, so I hope you don't mind. And for the rest of this talk, I'm going to be intentional when referencing foundation models or base models versus generative AI or GPTs, and try to focus the conversation on large language models in an enterprise context. Normally, when I do this, I sort of separate sort of external LLMs, which our enterprises have no control over, often, API only access type models like Cohere, Anthropic, and some of the offerings by Google Cloud Services and Vertex. And then you've got your internal LLMs like Meta too, and which, if you've been following, on Tuesday, Google Cloud announced was now available or would be soon available in the model garden that I believe Alan talked about as well. So that's great for the types of customers that I serve. Foundation models, put simply, are trained on a ton of data. I'm not going to go into too many details because just watch Peter's talk. They can be further tuned by the time you receive it for specific tasks. So you've got, Palm 2, and then you've got MedPalm for specific tasks for medical applications. And really briefly, how these base models, these foundation models are trained. They're trained on academic corpus, and so we're talking legal documents, patents, medical journals, general internet scraping, or crawling the web for Reddit and Twitter and pretty much any other service provider that is now locking down their APIs. That was a joke. Project Gutenberg. So we're talking like books and novels and code repos, Stack Overflow, math, YouTube media, that kind of stuff. And so foundation models can take the form of text, images for audio synthesis, videos like what Runway is doing, stable diffusion for images and that kind of stuff, right? In some cases, like with Bard, you might mix two modalities together and you'll get a generative AI solution that leverages, computer vision and the power of, large language models as well. Okay. I promised a field report of some sort. So here, the end result of, the technologies behind large language models or foundation models are very useful in the enterprise. I bucketed them. This is not exhaustive. They fall into information retrieval, automation and efficiency, content generation. And to date, since I sort of jumped into generative AI, I've seen impressive demos. I've built some of them, and they always sort of wow the room, and everyone gets that fuzzy feeling as to the power of these tools. But in an enterprise context, the cost for an enterprise to ship a generative AI solution without consideration for factual correctness, repeatability in development, consistency, and reliability is high enough to require guardrails of some sort, tests, safety mechanisms, automation, for reasons we'll get into. But before then, let's talk about some ways that these systems can be unreliable, because that's provocative, it gets you going, that's why you're here. There are lots of reasons. I've cut out a couple slides that sort of go deep into this for time, but I'll boil it down to three things. So I'm breaking down my thesis. What really inspired this talk, like I was talking about, was my fear that generative AI was going to be incorporated into search. So I'm going to use that to sort of frame my argument here. People look to search engines for fact. I don't care what you're doing, right? I typed in Noble Ackerson in Google just to see if there's anything. So try Googling yourself. You've done it a million times. I'm not the only egotistical person in the room. And if you find something inaccurate, guess what? There's a whole industry aimed at fixing errors on those links. You can't do that easily with a large language model. So left unchecked, these probabilistic, stochastic nature of GenAI could lead to more misinformation, disinformation, and societal harm. Yes, I know that these systems are being improved, and there's some UI tricks and user experience techniques that, say, for example, Google's new search experience is introducing, where it's very smart as to when it uses a GenAI response versus when it filters down links for you. And I think that's very innovative. And so these issues are boiled down into probability. Again, there's some element of randomness in how these systems, before you get a response, are rewarded based on making the best guess on the tokens that came before it, and also ultimately based on the data that they're trained on, right? So prompt design, and I'll get into this at the end of this talk, is very critical. You put in a garbage prompt, you'll get sexist, racist, and toxic responses out. And Alan was really good at explaining all of that. There's also knowledge gaps. Quite famously, OpenAI talks about how their models were not trained past 2021 September, right? And that's important, because when I go in and I type into some of these systems, what is an LLM? Believe it or not, even though these systems are powered by LLMs, it will not know what an LLM is. Sometimes it might get it right, but most of the time it'll get it wrong. They also overfit, right? Which means the responses have a behavior that repeat the exact copies of the text that they were trained upon, right? And that leads to situations where Sarah Silverman, a comedian in the United States, might sue a company. So imagine if you're this little startup building your GenAI tools, and Sarah Silverman comes and says, "You've just ripped off my entire book. You're out of business," right? And so enterprises are very, very cautious. And when I talk to them, they understand that in some cases they may not have full control over these systems. So they come to someone like me to sort of help them think through ways to solve these problems. And so with that, let's talk about what to do about it. I think I'm about 15 minutes in, so I think we can get through this. Before I go on, though, I want to stress that we've heard a lot about large language models, and we're seeing so many innovations with large language models, but a model is not the product. Let me repeat, the model is not the product. The GenAI, the generative AI solutions that you integrate into real software to solve real problems is the product, right? And so I'm going to zoom in into this framework that I designed for my customers, where these are essentially checkpoints, where you have your data input and your system input, where you're looking to mitigate any potential issues in your data inputs, your actual pipeline in order to sort of solve the problem. There's some evaluation techniques that you need to do. We'll take a look at that. And of course, if you sort of include experts to sort of review the outputs of these tools, as Victor was talking about before, there's some techniques that we'll go over. And so with this in mind, I'm going to be zooming in and out of every single one of these, hopefully in about 10 minutes. All right. So, you've built your fancy demo, you work for corporation X and you're solving a specific problem, and you built your tool. There are many paths to tame the unreliability, and let's define unreliability for the sake of this conversation as factual correctness, right? There are many ways to sort of tame it. And so I designed this framework to help my customers sort of think through what they need to do to adapt their existing machine learning operations pipelines, or sort of build new ones to help sort of rein in the uncertainty with outputs in these systems, right? Again, I have the word fine-tuning here, which you've probably heard a lot about. Fine-tuning does not teach your models new knowledge. The goal of model tuning or fine-tuning is to further improve the performance of the model for a specific task. So even with that MedPalm example, once you start integrating it, you can actually fine tune that on top of, fine tune that against your private data against that large language model. Okay. And so again, back to that systems, we can actually zoom into the data input and the system input and the system output. Okay. Again, lots of hype. Seen some impressive demos with LLMs, but again, they fall over the instant someone tries to use them within an enterprise context. And it's pretty tough to sort of rein in these things. So we're going to sort of zoom in further into, did the data preparation part, the fine tuning, if you need it, part, testing and deployment. Then we'll move next into your application pipeline, which is often a streaming pipeline. All right, so you can imagine this architecture being applied if you do choose to use GCP to host it. It works similarly. You just sort of swap in available services within that ecosystem. Okay. All right. So in practice within the enterprise, they're bringing in their domain-specific data sets. So help desk has chatbot data or conversations, reviews for their tools. Those are domain-specific data sets. I've got feedback data here, which is not necessarily RLHF, which is reinforcement learning with human feedback. That's actually different. That's a mistake. But this feedback is literally from your users, right? So to give your model that improvement flywheel. So for example, incorporating ratings or comments on generated text quality to improve your model's behavior. That's why you have that. And then lastly, there might be more for you, but data from your security and safety team, so logs and previous red teaming example to sort of augment your red or purple team's activities to further make your system a little bit more robust to adversarial attacks, right? And so then I'm going to get into further detail, but what I want to highlight here is, one big checkpoint, another big checkpoint is your evaluation. Another big checkpoint is, how you test this before you have your application pipeline ingest this. And when things are not right after your testing, you have a redeployment trigger using your, cloud build, or I'm sorry, your CI/CD pipeline of some sort. All right, I forgot to mention for your data versioning, you might want to use DVC or data version control or whatever is equivalent in your environment. All right, so now you sort of served your solution. You want to ensure that you have reliability checkpoints along the application pipeline as well. Alan talked about that a little bit, but let's sort of briefly look at an oversimplistic tool sort of pathway. What I'm going to focus on is mostly some of the techniques to ensure reliability, and very next I'll sort of show you one example. Some people use embeddings based on data that is uploaded, or it might use a database, or probably use an agent where it's basically an API call. So essentially your generative AI solution becomes a sort of smart with sort of crawling, accessing a predetermined system that has a RESTful API already on there. Of course, with all of this stuff, you need feedback loops for your team, and that normally gets stored in Feast or whatever feature store that you may have within your ecosystem. But as part of that whole flow, your user makes a request, goes through some magic, and which Alan has talked about, and you get a response back. One emergent technique this year in making generative pre-trained models reliable, especially in the enterprise, even though it's not foolproof, and I'll explain why, is something called Retrieval Augmented Generation, or RAG. And for the past few months, a bunch of novel approaches to help tame these, the unreliability of these models have come through. And in simple terms, a RAG is a technique to update the AI's knowledge, right? Or I flipped the last image that you saw, you know, vertically so that you, or horizontally, so that you can sort of see it from the sort of user's standpoint as I go through this. So again, sometimes you may want to add recent external knowledge. Say, for example, some of my initial demos for my customers were just semantic search example or sort of a RAG example, without consideration that, you know, within the enterprise, you know, new data, new knowledge is being added to a knowledge store every minute, right? And especially in larger organizations. And so you need a pipeline to sort of scale your data store at the end of this stuff. And so a retrieval augmented generation pipeline is very important. And sometimes, you know, depending on your ecosystem, you may have some tooling to sort of stitch this together. There's some open source solutions out there like Llama Index or LangChain, as was talked about before, to help you sort of stitch all of this together so that when a user makes a request of your system, you're able to get the latest and freshest information in order to give them a factually accurate in the way that we're defining it for this talk. But it's not a silver bullet, because there is, you know, if you're fetching real-time data from a database using, you know, Postgres or, you know, a PG vector, one of those types of tools, there's going to be latency. You know, you have to do some checks. And then I'll also talk about other techniques there in a second. I just want to sort of speed up a little bit for time. There's data quality issues. Now you're allowing this massively powerful, you know, galaxy scale trained LLM to only to adapt its knowledge onto your private data, right? So if your data quality sucks, well, you're going to get more inaccuracies. So that's a drawback. There's complexity in there, because, you know, we're talking about LangChain and Llama Index and this thing and, you know, ABAC and RBAC and all that stuff. There's going to be complexity, and with complexity comes cost. So, so I've walked you through the data input, the system input, the pipelines. Now let's talk about the system output and the product output, right? So for data, you want to employ, you've employed methods to sort of address hopefully missing or inconsistent data. You put in a pipeline in there. You've added a little bit more complexity, but now you're starting to work on sort of the application pipelines, how your system interacts with humans. And I love Alan's talk, not because we're friends, because it sort of helps me sort of cut the corners as to how to make these things reliable. So what I swapped some of my code slides with was something that I'm researching for a book that I'm coming back with, which is, the importance of talking or speaking to these systems. I believe Ilya Sutskever of OpenAI said, the most powerful programming language is English. And so this is normalize that to say is language, just to be more inclusive. But language is hard. Conversation is hard. And in the late 60s, a professor, a philosopher called Paul Grice identified something called the cooperative principle. And he's a well-renowned linguist. And so one thing that I want to sort of leave with you is sort of think about some of the lessons that he taught when you're sort of crafting your system from a developer experience, or just sort of things that you want to account for when you're evaluating how your users are interacting with your solution from the CX or this customer experience or the user experience, right? And so Paul Grice talks about 4 maxims, right? He talks about quality, quantity, relevance, and manner. For quality, we want to talk about, he's focusing on how truthful we are. For quantity, he's talking about how informative we are. There's relevance. And with manner, he's talking about how clear we are. And these can be used as sort of reliable guidelines when you are doing your in-context learning or prompt engineering, and on how you sort of frame your prompts. And so, when you want to put a simple example, overly simple example, when you sort of want to sort of train it to sort of say, tell me about AI, that may, for, the quality or even the quantity maxim, you may want to sort of think of something like being a little bit more illustrative, like, explain the key principles of machine learning and just sort of provide it with examples, as Alan and Victor were talking about earlier. So this aligns with your model's in-context learning or prompt engineering abilities, allowing it to generate more targeted and useful information. Another technique to sort of rein in, what you may not be able to control, right? Note what I'm doing here. You weren't able to control the inputs, right, with your data, with the interacting with a large language model, but we constrained it and made it a little smart with things like RAG and vector databases, that kind of stuff. And then how your users are going to work with this thing also is a little unpredictable. You have no control over it because you can account for 99 different scenarios to sort of protect your system. I guarantee you launch your app and you ship and you pop your champagne, they're going to find 101 way to break your system, right? And so there's tools like guardrails that allows you to add structure, type, and quality guarantees to your large language model outputs. And because whoever came up with guardrails is super smart, the Rails part is called reliable markup language. And there's a guardrails, getguardrails.ai is one. This image here is from NVIDIA, who recently launched Nemo. And so you're using these Rails languages as sort of a buttress for your solution to define things like the data types that your users are going to be interacting with, corrective actions, to validate and correct LLMs before generating a response. So you've probably heard how other LLMs do it. When you're using it, it says, as an AI, I can't talk about politics. So think about those types of solutions as well. Let's land this plane. So to land this plane, we talk about some key takeaways, right? We've talked about, your data inputs, your system inputs, your system outputs, and your product outputs. Here are some mitigation techniques that we look at: robust metrics and security measures for the data input, task decomposition, feedback loops, guardrails or defensive UX for the system IO. And then, of course, product output has, I want to sort of go back to, I cut out a slide here, but you want to sort of properly explain or clearly explain what your system can and can't do. And then, allow your users to opt out or, correct, any issues or give you feedback as you're going along. I won't get into this too much. I think I'm at time or maybe close to it. And so these are methods for reliability and some continued research. You will see some of this data come out over the next couple months as I sort of get too close to publishing my book sometime next year, if I get time. And I want to leave you with some resources because, why not? I will make these slides available. There's a lot of interesting work, research that you can apply, and I'm going to make that available for you. That's my gift. And yes, we can conclude, how we test our prompts, how we sort of put guardrails around our systems. Regardless of what we do, that conversation with the machine is very important. So it's worth revisiting, linguists and just sort of mapping some, being a creative technologist, sort of map some out of domain context to what you're trying to do when having your users converse with your generative AI solution. And that is my talk. If you want to read about the full context of my talk, it's a short read and it's going to be on my Medium. Sorry for shilling so much. And that's it. Thank you. Questions. Let me see, try to pull up my questions here. Oh gosh, let's see. Is there any standards for testing the capabilities of LLM based on task types? I think I may be wrong here. I don't know this answer to this question, but I'm going to go on a limb to say we're in the Wild West where there are no standards yet. there's some good best practices. If you sort of look at some of the resources that I provided, evaluation using benchmarks, publicly available benchmarks is one. At some point, you notice I had A/B testing. So depending on your use case, you may want to get experts if you can afford it to help you evaluate or test the responses in your system.
Excellent presentation, Noble. Just a quick question. And so in implementing RAG, so retrieval augmented generation, of course, one of the challenges that I see is that, like, especially when you try to do it, is it's in some cases it can actually hurt performance. And so your ability to retrieve the right documents sort of has this outsized effect on the sort of value you get overall out of that whole experience. And so, like, do you tend to see things like that? Like, how often do you see challenges like that sort of coming up, just in general?
There are tons of challenges, and I think I scratched the surface. So I cut a lot of slides back. I also have a similar example with semantic search. So I'll be talking about this a lot this fall at Voice and AI, actually with Alan. But to your question, outside of latency, data quality, complexity, and cost, there's also security risks. So fetching data from external sources some can potentially pose security risks like data breaches or unauthorized access, if that sort of goes to your question. And so you have to add more complexity, right? Yeah. You have to look at role-based access controls or attribute-based access controls and sort of incorporate that as well.
Yeah, great. I think that's a great point, because you don't want the LLM answering questions using data that user should not have access to. So
right.
Cool.
I didn't have time to get into all of it, but you're absolutely right. It is a nightmare, especially when you have, one good question that I got from someone who knew nothing about the system. They were impressed at the demo, a construction firm that I helped out. But then they go, so what do we do with our Postgres database and our systems? Because it already has all those checks, all those sort of gates where they have an ABAC sort of protocol in there, not just based on the role of the user, but certain attributes that should be exposed to the user. Well, none of, and of course my response was, well, this is a demo. So,